Hi, today we're going to be building a screen transition using Unity Shader Graph. So what is Shader Graph? Shader Graph is Unity's node-based editor to create shaders in a way which is much more intuitive than writing out a shader script by hand. As you can see, you can do pretty powerful things with this, but we are just going to explore the basics with our transition effect today. So why Shader Graph? Shader Graph is a lot easier than writing a shader by hand. On the right, you can see an example of a shader. This is actually the compiled output of the shader we're going to be creating, which turned out to be around 6,000 lines long after Unity auto-generated it. Of course, a shader you write by hand probably would be a little shorter because it doesn't have to include the boilerplate, but they can be seriously complicated. Another benefit of Shader Graph is that it's a lot easier to modify your shader down the line, because you can simply drag and drop the connections between nodes together, whereas in a handwritten shader, it can be quite difficult to move logic around in a way that doesn't break your shader. Now that we know some of the motivation behind it, this is what we're going to be making. All right, let's get into it. First, create a new project in Unity using the 3D URP template. You may name it whatever you want. I'm going to name mine Spotlight Wipe Demo. Now we're going to quickly set up our scene with a few pre-made assets. You can find them in the description. We're going to reset the position of the chessboard to the center and do the same with the chess piece. We are also going to, just for aesthetic reasons, tweak the directional light to give a little bit more character to the scene. Finally, we're going to tweak the position of the camera to center on the chess piece, trying our best to get it in the center of the frame so that it works well with the effect later. Lastly, we're going to parent the camera to the chess piece so that it moves with it. At this time, I'm also going to add a simple character controller to the chess piece, which I've also included in the description. This is completely optional, but will allow us to move around the chess piece later if we wish. Like so. Now that we've got our scene set up, we can start working on our effect. The first thing you're going to want to do is add a canvas to the scene, which you can find under the UI submenu. We're going to leave this as canvas and create another UI element in it, which is going to be an image. We're going to rename this to wipe effect. So this image is going to be placed on the canvas, which if you zoom out is a huge rectangle over our scene. So this image is going to be the black part of our effect, and so we are actually going to want it to take up the full space. So we are going to hold down Alt on the keyboard, or Option if you're on Mac, and click on the bottom right button here. This makes it take up the full width of the canvas, no matter if we resize our game window or not. Now that we've got that out of the way, we're going to start creating our effect. So the first thing we are going to want to do is create a new shader graph, and this is going to be a URP lit shader graph. Ideally, UI elements would be unlit, but the URP unlit shader does not actually work with UI elements currently in Unity, so we are going to stick with lit, and I have a workaround for some of the visual nuances that come with that. We're going to call this Spotlight Wipe. And now that that's created, we also want to create a material to place it on. So we're going to create a new material and call this Spotlight Material, and drag our shader graph onto the material. Next, we're going to drag our material onto our wipe effect so we can start to see our changes. So now that we've got our material applied, let's open up our shader graph and start working on it. We're also going to put the scene tab split on the left so that we can see what is happening to our actual object in the scene. So the first thing we're going to want to do is create our circle. So we're going to go to Create node and search for ellipse. We're going to bring that in, and for now, let's just output it to the base color. So now we can see our main preview starting to update. Typically when a shader is updating, it'll appear the cyan color, but you may notice it's not appearing differently in the scene yet, and that's because we need to save our asset every time we make a change. Once our asset is saved, we can see our ellipse has appeared here. So you may also notice that the colors do not match, and that is because of the lit shader issue I mentioned earlier. If we actually check our game view, we will see that it appears as it should, but it just appears differently in the scene view. To minimize this issue, we can actually set our smoothness to 0, and it will make it look a little closer to reality in our scene view. Next, we're going to fix the issue you see here, which is that the circle is stretched across the canvas, and this gets worse the more you change the window. So ideally, we want the circle to be a circle. So to do this, we are going to add a component to our wipe effect, and that is going to be the aspect ratio filter. We're going to set our aspect mode to envelope parent because we want our wipe effect to completely envelop our parent. Next, we're going to set our aspect ratio to 1, and we have the circle as we wanted. Now that we've got our circle, we are going to use it to cut out of this black background rather than just appearing as a white circle on it. So the first thing we need to do in order to start that is go to Graph Settings here and scroll down and enable alpha clipping. This will allow us to use our texture here to set the alpha value. While we're here, we're also going to disable cast shadows because we don't actually want our UI to cast shadows over the scene. We're going to make this smaller again so we have a little more space. And here, instead of base color, we're going to delete this link and instead drag it to alpha. We're also going to change the base color to black since it's no longer set by our texture. If we click save, then we can see our change in the scene. But we notice it's actually the opposite of what we want. And that's because the alpha value is decided by the white and black value of the texture. If a part of the texture is white, then it will be fully opaque, and if it is black, it will be fully transparent. If you have values in between, they are typically semi-transparent values, but in this case we are using alpha to clip, and so it will simply have a threshold at which it is transparent or not transparent. To fix our current issue, we are going to simply invert the colors of our circle. And to do this, we are going to right-click, click Create Node, and search for Invert Colors. Adding this node in, we are going to drag our ellipse into the in socket and put the out socket into the alpha of our fragment shader. Next, we just need to check the red channel checkbox, and it will invert the colors as we want. If we click save, we can see our changes made in the scene. So now we've got our circle punched out of the black background as we want. Next, we're going to allow our shader to be controlled via a float value in the material. To do this, we're going to add an input, which is going to be a float. We're going to call it circle size. At this stage, we can also add another input, which is going to be a color, and we can call this background. This will allow us to change the background color from black to another color later if we want. So we're going to drag the background color in and connect it to the base color. Similarly, we're going to drag our circle size in and connect it to the width and height of our ellipse. Click Save, and you may notice that our scene no longer has a circle in it, and that's because the default value of our circle is set to 0. For the sake of displaying it, I'm going to set the default value to 0.5 so that we can always see the circle. The background color's default is usually set to black. If we hit save, still nothing will happen because our shader already has this value set. So we can change this to 0.5 and our circle will appear as usual. But now, instead of having to resave our shader graph every time, we can simply control our circle size directly from our material. And this is what will allow us to change it in real time in the game. Similarly, we can also set our background color to whatever we want. I'm going to leave it as black. So now that we have our circle controllable, we want to animate it. We are going to go to our wipe effect and add an animator. We also want to add a controller, so we are going to create one. Go down here to Animator Controller, and we are going to call this Wipe Animator. We can then drag this controller into the controller slot of the animator, and then we can try to start animating. So if we open up our animator, I'm actually going to drag the scene view back over to the right here for a moment. Next, to start animating, we are going to go to Window, Animation, Animation, and we are going to dock this window into this panel here. Next, we're going to select our wipe effect and click Create. This is going to create a new animation for us, which I'm going to call Circle In. So now that we've created this effect, we can click Add Property to add the property we want to animate. But unfortunately, if we check in our image properties, we have a material, but it does not let us control the other properties of the material. So this will actually not do what we want. To get around this fact, we are going to create a script which will essentially set the properties of the material for us and animate the properties of the script instead. To do that, let's create a new C# script and call it wipe controller. Now let's open that in Rider. Once we're in Rider, we can see the contents of our script. To start off, we're going to store some references to some components in our game object. First of these is going to be the animator. And so this is going to be for later. And we are also going to have a reference to our image. And so we're going to type in image here, and we don't want Unity engine.ui elements, we actually want Unity engine.ui. So make sure to autocomplete that one to import the right package. We're going to call this one image. Next, we want a public field, which is going to be a float and will be called circle size. This is what we are going to be animating and what we will use to set our material. Next, we want to set references to our animator and image components, and we will do that with animator equals GameObject.getComponent. We are going to choose the generic option and say get our animator. We're going to do the same thing for our image. Now that we've got these, we are going to set a default value for our circle size, which in this case will be 0 because we're typically going to want to animate our circle getting larger from 0 to enter our scene. Here, we're going to want to say image.material for rendering dot set float. And so this is going to set one of the floats that we expose in our shader. And so in this case, we want to set our circle size float. So one of the unique things to keep in mind about the shaders and shader graph editor as well is that the properties are not named quite the same as you do in the shader graph editor. So in this case, our property is going to be underscore circle underscore size. You can check the name of your property if you named it something different, by going into your shader graph editor, clicking on circle size, and looking at what the reference name is. Now that we've got our name, we are going to set it to a value, and that value is going to be circle size, which is the variable we have declared up here. You may notice we have a yellow underline here, and that's because there is actually a more efficient way to access that particular property, and that is to find the ID of the property and use that instead. Here we're going to create a private read-only because it won't need to change over the course of our runtime. Int underscore circle size ID, and we're going to set this to shader dot property to ID and put in our underscore circle underscore size. Next, we're going to replace circle size down here with our circle size ID. This will speed up runtime, and since we're using our script to essentially act as a link to our material, we want this to be as quick as possible. Now that we've done this, we can start animating our scene. Back in Unity, we're going to want to select our wipe effect again, and now we're going to remove the property we created before. We're going to select wipe effect and add the new script that we created, which is wipe controller. We're just going to drag it in, and you can see that we have access to the circle size property, which is how we're going to animate it. Unfortunately, this doesn't actually preview in real time like the material does, so to preview values, you'll still want to change the material. We're going to set this to 0. And now we can actually animate that property. So we're going to go to Add Property, Wipe Controller Script, and add our circle size. So now we can animate this circle as we choose. I'm going to drag this out to 1.5 seconds, and we are going to animate from, in this case this is circle in, so this is our transition in effect. So we're going to want to go from 0 to a final value of 1. Now along the way we can be a little creative with our effect. For example, we can say we're going to go all the way to 0.25 in less time, and then we're going to hold that for a few seconds. So let's say we're still at 0.25 here. Then we're going to actually decrease a little bit, and then it will increase all the way back up to 1. And so now if we hit play on our scene, we can see what that looks like. And so this does the effect that we want. It is a little small though. So in this case, we are going to actually edit our shader graph script. And that's because of a slight nuance of our material right now, and that is that once we get to a circle size of 1, we still have the corners of the screen black. And so ideally, when we want circle size to be 1, we actually want there to be no black left on the screen so that it's easier to animate. And so in this case, we are going to go back into our shader graph and do a little bit of math to help us with this. And so in this case, we're going to create a new node, which is going to be a multiply node. Now we are going to multiply our circle size by a value of 1.41. And 1.41 specifically because that is the square root of 2. And that will give us the correct value to have our circle just outside of the aspect ratio square, meaning it will be just off screen. Next, we're going to set the width and height of our ellipse to our new multiplied value and hit save. Going back into our scene, we can now see that our circle size, once it is 1, it is off of our rectangle. We can see once our shader loads in that it animates about as we expect. Now that we've got this, we are also going to add a few more effects so that we can animate circle out and hold states so that the animation does not simply loop infinitely. So to do that, we're going to click on wipe effect again, click on circle in to enable our animation menu, and click Create New Clip. Now we're going to create circle out. This is essentially going to be the opposite effect of the one we made before. So we are going to go from a value of 1, where the circle is the maximum size, and go down to 0, where the circle is minimum size, meaning the screen is all black. Now we're going to do a similar kind of thing, where we are going to go down to a value of 0.75 here, and then a little bit later we are going to still be at a value of 0.75. We are also going to move our final node out to 1.5 seconds. Then we are going to set this value to 0.85 and then let it go down to 0. We're going to shift this a little bit to the left. Now, if we switch the default state in our animator, we can see this second animation in our scene. And so this animates out as we expect. In this case, the circle's a little big, so I'm actually going to tweak that a little bit. So instead of 0.75 on our circle out, we're actually probably going to want to set this to 0.25 to match our circle in our other animation. So this, instead of 0.85, will be 0.35. And we are going to shift all of these over to the right. And this is one of the benefits of using this animator setup, because you don't need to tweak a shader script. You can simply do all of this in the animator directly. Makes it a lot easier to quickly make changes to your animation. Clicking play on our scene, we have around the speed that we want. So now we are going to set up some states so that we can animate in and out when we want, rather than simply replaying one animation infinitely. So to do that, we are going to create 2 more animation states, and so that is going to be our hold in.anim. And so this is just going to be a circle size of 1, which is our in state, and we're going to delete the other keyframe so that this just holds this value. We are also going to create the opposite, which is hold out, so that we can keep the screen black. This is going to be circle size of 0, and delete the other keyframe. Next, now is a good time to disable the loop time on circle in and circle out, because we don't actually want these animations to loop. Hold in and hold out we do want to loop, because they will be on the screen potentially indefinitely. Now that we've got all of our animations, we are going to set hold out as our default layer state, because we want our scene to start off with the screen black, and then animate the circle in to reveal our character. Next, we are going to organize our rectangle states into a square and make transitions between them. So our hold out will transition to circle in. Then once we've circled in, we are going to hold in. Then at some point we will transition to a circle out. And then once we've circled out, we want to hold out. To control these transitions, we are going to create 2 triggers, one called in and one called out. Next, we are going to set the conditions for these transitions. So to go to hold out from circle in, we want the in condition to be true. And to go from hold in to circle out, we want the out condition to be true. Similarly, we are going to also disable the exit time checkbox in these two, because we don't actually want a delay in our transition. Now that we've created these, we want some way to trigger our animation states from another function, but in this case we're going to use keyboard input. So when we press the spacebar, we are going to transition between in and out. To do this, we are going to modify our wipe controller script that we made earlier. In our wipe controller, we are going to create two methods, animate in and animate out. And both of these will be void methods because they don't return anything. Within these, we are going to set a trigger state on the animator, which we've already stored a reference to. So we're going to set trigger, and this is going to be in. And similarly, we are going to set the out trigger in animate out. To store which state we're in, we are going to have another private boolean. This is just so that when we press spacebar, it toggles between them. So private bool is in equals false. Now, when we animate in, we are going to set is in to true and do the opposite in our animate out. Finally, we want to trigger our animation in the update method when we press the spacebar. So we are going to say input.get key down key.space or keycode.space. And in this case, we want to say if we are already animated in, then we want to animate out. And otherwise, we want to animate in. So now that we've got this set up, our animation should work as expected. Swapping back into Unity, we can check if our changes have worked. Hitting play, we can see we're in the hold out state as expected, and when we press spacebar, we animate in, and now we are in the hold in state. Now we can press spacebar again, and it will change to circle out and then hold out. And so that is the completed effect. Now you may be wondering why we went to all this trouble going through the shader graph to create a circle, and that is a good question. So the shader graph is a lot more powerful than just creating circles, as you might imagine. And we can pretty easily, once we've got this set up, create a bunch of different effects. So for example, instead of this information, these nodes here, we can create a new node called Vornoi. And so here we've got our Vornoi texture, which is a procedurally generated texture, which has a kind of natural looking circle-y pattern to it, and we are going to set that to our alpha instead. To control this, we are going to add a subtract node, and we are going to take our Vornoi and subtract our circle size attribute, which we're temporarily repurposing, so that we can control our Vornoi texture. Next, we're going to use the output of the subtract node to replace our alpha. If we hit save asset and go into our scene, we can see that our black background is now full of holes. And if we change our circle size attribute in our material, we can see that this actually controls the size of the holes. And so this allows you to create all kinds of different effects if you want, and you can even stack multiple layers of Vornoi together to get a more natural effect than just these large circles. Overall, there's a ton you can do with the shader editor, and this is just scratching the surface. But this provides a template for some UI screen-based effects that you can use in your own project. And with that, thank you for watching, and a link to the final result as well as all the assets I used is in the description.